be upon you and God's mercy and blessings. God willing, we will talk about the protection system in electrical stations. The first thing we will start with is the protection system, which consists of 4 parts. The first thing is the protection system, which is considered the station systems responsible for delivering quality values and aircraft from the primary circuit, such as the bus bar or cable, to the secondary circuit, which is expanded upon by the protection relay. The stages of protection involve analyzing the quality value and aircraft so that it can cause the current or voltage by sending a trip signal to the circuit breaker. The circuit breaker uses the trip signal from the protection relay and disconnects the circuit to isolate the voltage part from the current. The last thing is the DC supply, which is used to power the protection rotor at the station with a quality of 125 VDC. Here, the protection rotor is meant in addition to powering the control rotor. Now, we want to look together at a simple protection system for a single bus, single breaker scheme. Here, I have a single bus bar. To protect the system, first connect instrument transformers, a current transformer, in series, and a voltage transformer, in barrel with the primary circuit. In the secondary circuit, CT and VT connect to the protection relay, which sends a disconnect signal via the circuit breaker trip coil using DC supply, completing the circuit breaker tripping circuit. And the VT is connected to the protection relay. The protection relay issues a trip signal through the output contact to the circuit breaker trip coil with the help of the DC supply. Thus, the circuit is formed breaker tripping circuit. Assume that the circuit breaker is closed and at some moment there is a voltage on the feeder bus bar, which will be the source that starts supplying this voltage. So how does the protection system work? The CT and VT will start supplying the value of the current and voltage, and based on the settings inside the relay will be able to determine the fault. It will trip the circuit breaker to disconnect to isolate the voltage from the rest of the healthy system. The circuit breaker opens to extinguish the arc. Once open, the current and voltage will return to normal and the protection system will receive a message and reset the trip command. We will now talk about all the components in the protective system, starting with the instrument transformers. Instrument transformers are devices used for 2 purposes. First, they provide power and voltage values at lower levels that we can handle with standard and protection parts. Second, they adjust the isolation between the primary and secondary circuits to a very high value, which is connected to the standard and protection parts. Instrument transformers consist of current transformers and voltage transformers. There are 3 types of current transformers: wound or busbar type, toroidal or window type, and bushing type. As for voltage transformers, there are 3 types: electromagnetic type, capacitor type, and optical type. For the current transformer, it provides values for relays, meters, SCADA, transducers. CT ratio is primary to secondary, usually 1A or 5A, like 2000.1 or 1200.5. CT ratio equation: I primary, I secondary, I N secondary, N primary. Current ratio inversely proportional to turns ratio. Therefore, the CT ratio equation is expressed as I primary over I secondary equals N secondary over N primary, meaning the current ratio is inversely proportional to the turns ratio. As for the voltage transformer, it is used with relays, meters, SCADA, transducers, and other devices. The VT ratio is expressed as the ratio between the primary and secondary voltage. Usually, the voltage in question is a single-phase voltage. For example, if I have a medium voltage, I would say that the VT ratio is 13800 over the square root of 3 to 115 over the square root of 3. 3 to 115 over the square root of 3. So the equation VT ratio is V primer over V secondary equals N primer over N secondary, meaning voltage ratio is directly proportional to turns ratio. The second element we have is the circuit breaker, and the circuit breaker is used to interrupt the current flow after the protection relay sees a voltage and sends it a trip command. The circuit breaker can get a classification based on the RC quenching medium, such as SF6, oil, air, and vacuum circuit breakers, such as SF6, oil, air, and vacuum circuit breakers. The third element is the DC supply. The DC supply voltage is used for powering the control and protection circuits in the stations. So the question now is, why don't we use AC supply? Of course, I could use the AC supply available at the station to power the control and protection circuits. But there are 2 problems with using the AC supply. Firstly, if the primary supply at the station fails, I won't have a supply to power the control and protection circuits. Secondly, if there is a fault in the system, the voltage level might drop, and at that point, it might not be sufficient to operate the protection or control circuits. So, what is the advantage of using DC? Firstly, you can store DC in batteries, allowing you to use it at any time, even if the main AC supply is interrupted. Secondly, in the case of DC, the voltage remains constant and does not change with fluctuations in the AC voltage, even if there is a fault in the main AC supply. Therefore, DC provides higher reliability and also offers a backup system. The fourth science is protection relay, IED. It includes functions like overcurrent, differential, distance. It has digital inputs for data like statuses and alarms, and analog inputs like CT and VT. Programmable LEDs indicate alarms or protection trips. Inputs, which are used to deliver data to the relays such as statuses and alarms, and analog inputs, which are represented by CT and VT inputs. Programmable LEDs are used as visual indications and can be programmed with an alarm or protection trip for any protection function. Hardware output, which consists of contact output or transistor output, is programmed with an alarm or protection trip to disconnect the circuit breaker. The communication card is used to connect the relays with each other, for example, in end-to-end scenarios like in transmission systems, or to connect the relay with the system interface, such as when stations have a SAS or substation automation system. The HMI, or human-machine interface, allows you to draw a dynamic single-line diagram. Additionally, you can use it to change the settings in the relay and also obtain different measurements from it. With this, we have completed the protection system elements.